This video is a little bit of a pre-lab preparing you guys for our next titration, which is the pH titration. A fancy way to say pH titration is potentiometric titration, and that's what we will be doing. The purpose of your lab is to find basically the unknown concentration of two different acids. We're going to be on day one titrating a strong acid against a known concentration of base, specifically hydrochloric acid against sodium hydroxide. And on day two, we're going to be titrating vinegar, a weak acid, against that same known concentration of sodium hydroxide. We've already talked a lot in class about titration curves and what they're supposed to look like, and now you're actually going to see them live and in person. Part of the lab will also be comparing and contrasting the characteristics of the titration curves. What equipment will you need to do this lab? There is a lot of really expensive and really cool, sexy equipment that we're going to use, and I'm going to go through just so you'll learn the names of them. Some of them you've used, some you haven't, but again, I'm going to go through them just so you have a familiarity with those. So let's start looking at some of the equipment here on the left. First you have this burette clamp. This burette clamp obviously holds the burette. And we can hold two burettes at one time, which we won't be doing in our class, but that is a possibility because of the two sides of the burette clamp. You can place the burette clamp on this ring stand and it will screw on right there, and you'll be able to adjust that height up and down in order to get everything appropriately placed. So just know that you can adjust the clamp pretty easily. We know that this is a burette. You guys have already seen this. And then you have a little baby, cute little baby. This is not to scale. This is a little burette funnel that you'll put in the top of the burette, and you can use it to fill your burette so you don't spill sodium hydroxide everywhere. On the right here, we have some other equipment you're going to be using. This is what we generally call a utility clamp. The utility clamp is going to be used to hold the pH sensor. The pH sensor, you guys got a little view of it when you did the KA lab and you had to check that pH of your solution. You're going to be using it a lot more for this lab. I just wanted to point something out to you. Right there at the bottom of that pH sensor is a porous glass ball that is super fragile, and that is, if that's broken, the pH sensor is kaput. So just know that we need to make sure our stir bar doesn't knock into that, and you need to treat this very, very carefully, this sensor setup, because these are somewhere in the range of $120 to replace, and we don't have money to replace them, so students will have to chip in to pay for anything of these that they break. So I've never broken one myself, so I know it's possible not to break them if you're careful, so just please be careful with it. Right here you have your beaker with your little magnetic stir on your magnetic stir plate. You used this already before this year. Same thing as before, gentle stirring. We want constant motion of liquid around this pH sensor in order to get a smooth titration curve. So get that rolling nice and gently. And then we have the LabQuest, and you're going to be creating a titration curve on here that's going to look something more like that. And that's it for the equipment. So let's talk about the procedure itself. So when you're setting up the equipment to start the procedure, it's going to be kind of chaotic as far as adjustment. It's like a Jenga puzzle here. You're going to need to make sure that everything is placed where you can still drop stuff into the beaker, drop sodium hydroxide in the beaker, and you can still have your pH sensor comfortably submerged in the water. So you're going to have to do a lot of adjusting. The first thing you're going to do is pipette or syringe a particular amount of acid as described in the lab into your beaker. And like we've done before, where I say just chunk in some extra water, put a little bit of extra water in there to beef up the volume, because the water level has to cover that pH sensor. And you're going to be using a very small amount of acid, so we definitely will need to beef up the volume. You're going to put your beaker on the stir and put the stir bar in there, and then you want to set up your pH sensor. Now, when you have your pH sensor, it'll already be plugged into the LabQuest in channel 1, but what's different this time that you haven't dealt with before is the pH sensor comes in its own storage solution, so you're not going to just put this whole thing into the actual water. You have to unscrew this top and free the sensor. Do not just yank the sensor out of the rubber stopper here. You have to unscrew the top. And then the top will just remain on the sensor while you do your pH titration. The top's actually a really good little handy thing to use in the utility clamp because it widens the surface a little bit that the clamp can hold on to. So I would just slide the top up and then put the utility clamp right around the top. So then you're going to adjust your utility clamp, this guy, up and down in order to A, not be in the way of the burette, and B, in order to be submerged in the liquid. So this is pretty much the apparatus that you need to create right there, or the setup that you need to create. Again, just a reminder, as you stir, you make sure that your stirrer is not bonking into that pH sensor because that could potentially crack that porous glass, and that would just be really bad news. And you also need to make sure your burette is placed in a way that we can drip base into the acid. So it's quite a bit to set up, and your first time will be a little but you'll get good at it. By the end of the year, you'll be a pro. So you're going to make sure your pH sensor is submerged. Then you're going to start the stir and make sure, again, it doesn't hit that sensor. While you're doing this, someone else can be filling up, rinsing, and cleaning out that burette and filling it up with sodium hydroxide. Just remember, whenever you fill burettes, you clean it out with whatever you're putting into the burette. You don't clean it with water and then just fill it up. You want to rinse it with the sodium hydroxide so you don't end up diluting your standard sodium hydroxide. You're going to attach the burette to the burette clamp and arrange it just like this. So I feel like I should erase all of this because it's really ugly and you can't see the pretty setup. So if you have any questions about this, please let Miss Rozier or I know so we can help you out and get all that straightened up before you actually start your titration. Once you have the setup done, you're then going to just follow the LabQuest setup instructions. Okay, when you start your titration, you're going to be incrementally adding the sodium hydroxide, and you want to collect as many data points as possible. Your very first data point you're going to collect, or what they use the word keep on your, it's a keep button on your LabQuest, where that will record the pH at any one moment in time, and you put in the volume that you've read on the burette. So your very first data point, you're going to have a 0 volume. You're going to fill your burette to the 000 mil mark. You have to. You can't do what we did before and like anywhere at the beginning just record the initial volume. Your initial volume has to be 0. And so your very first kept point, you're going to read the pH and put in 0 for that first volume. And then you're going to just add small increments of base at a time, and it'll give you clues in the lab about how many pH units you want to see change before you stop and keep the data point. It says to wait for, the pH to stabilize, but don't wait forever. Just as soon as it slows down, the pH change slows down and it kind of stabilizes, go ahead and hit the keep button. Because as you're standing there breathing into the beaker, it's getting more acidic because it just doesn't stabilize really well is my point. So, get into a pattern, wait for it to pretty much stabilize, hit keep, enter your mils, and then keep going. You're going to just collect as many data points as you can. The more the better. You can't collect too many. The only way if it's too many if it takes you more than the class period to get done. At one point, you're going to really start to see that pH value jump, and that's going to be right when you're near the equivalence point. So hopefully you'll start to see the big pH change happening before you reach this point, because once you're around this area right here, you need to be like adding the base dropwise. And then once your pH reaches maximum and stabilizes, you call it a day with your curve. So this is a typical strong titration curve, as I'm sure you remember from lecture. This is the kind of curve we're going to see on day 1. On day 2, you're going to have a weak strong curve, which looks a little bit different, and part of your job will be to describe the differences that exist between the two curves. Now, as far as the equivalence point, you're going to be able to find the equivalence point 2 different ways, and I want you to do both ways, and then we're going to compare them. The first is to determine the middle of that sharp rise. We know that in a strong, that should somewhere be near 7. I'm not going to depend on that 7 though, because of the calibration of the pH sensors. It might not be exactly 7, but it doesn't matter, because regardless of where it is on the y-axis, the sharp rise, what we care about, the number we want, is what is the mil value of the middle of the sharp rise, not what the pH value is. So you're going to go ahead and read the mil value probably at the start of the sharp rise and then at the end of the sharp rise, and then take the average. Your instructions in the lab kind of describes that to you. The reason we do the average is because this rise is so steep, we can't always find a data point in the middle that we measure. A lot of times you'll have data, and then nothing, and then data, and so you get like this, and there's nothing in between. When that is the case, you need to find the start of the sharp rise and the end, and then take the average to find that point. That's your classical way of finding the equivalence point. And again, that's going to be explained to you in your lab. We are in the age of technology now, so we have an amazing LabQuest that allows alternative ways to find the equivalence point. So another way, and those of you who are in calculus understand that, another way we can find this point where the middle of the sharp rise is technically the place where we have the steepest point of inflection, the tangent to the curve that's most steep, and to find that in calculus, we say we take the derivative. So what this graph is right here, is a graph of all the slopes tangent, all the slopes of the line tangent to the curve at all the different points that you took. The very, very top will be the mil value of the steepest inflection. So that's the actual value that you're going to use as your equivalence point. That should hopefully come pretty dang close to the equivalence point you did by kind of observing what the middle of the sharp rise volume was. Okay, so you're going to do both, compare. If I had to pick one to use though, this one right here is definitely a more accurate option. Now for calculations. You have done these calculations a lot already, so this is definitely something you're familiar with. Like before, we're going to utilize the equivalence point to find the mils of base. From knowing the mils of base and the molarity of the base, we can then calculate the moles of the base. And we know that at the equivalence point, the moles of the base equals the moles of the acid. Once we find the moles of acid, then and those are the moles that we originally put into the beaker with the syringe. We're going to take those moles and we're going to divide them by that volume in liters, and that should give us the unknown molarity. Simple, simple. Then you're going to have a lot of post-lab questions to answer, which will cover mainly comparisons of the strong versus the strong-weak titration curve. All right, so now you're going to work on that PreLab, and you're going to come with your game face on and you're going to be ready, because the first one you're going to do is going to be crazy and it's going to be frustrating, but you're going to become master titrators by the end of it. So please be prepared. Please, if you have questions about this video, come talk to your teacher. And if you have questions about your PreLab, come talk to your teacher. but this stuff is actually really, really important for preparation for the AP. All right, see you guys later.